Good day to everyone. So we are doing the vertical projectile motion, that is the velocity time graph today. I'll share the link for the entire topic, but now I came with the easiest way of drawing the graph and interpreting the graph. Alright, so let's go straight to it. Don't forget to click the subscribe button. Thank you for your subscription. The velocity time graph, what is important is to understand the shape first, because there is a mark for the shape. Then on how to draw it. First of all, you must understand that we have that equation V, which is equal to the initial velocity plus acceleration delta t. Then you must know that the time is always on the x-axis, right? And if you can look here, we have the functions, that is y is equal to mx plus c. Then we have y is equal to ax squared. Then we have y is equal to a over x minus p plus q. So this one is a linear function. The focus is on x. There is an exponent which is 1 there. This one is parabolic. It's a parabolic function. The linear is a straight line. There is a what? X. There is 2 as an exponent. Okay. Then here x is a denominator, that is hyperbolic. So it's a curve-like graph. Hyperbola. Okay. Now, if you can look here, this is our time, which is always on the x-axis, and the exponent is 1, which means this one is our x, and since the exponent is 1, is a linear function, which means the velocity time graph will always be a straight line, no matter what, right? Then if you can rearrange here, lento ithi velocity time graph, and you know that the coordinates bangu xy. So since coordinates bangu xy, ithethe ukuthi velocity is our y, saying y nansi here. This is our y. Then if you can look here, when we divide the velocity by time, remember we said y lo, then the time is what? Is x. We get what? The acceleration, meaning that the acceleration is the gradient in this case, because incamathele apha ku-x, the acceleration is the gradient, change in y over change in x. So the gradient is acceleration. Okay, so this is the gradient. Y is equal to mx plus c. This is c, if you can rearrange. All right, now we need to memorize here a bit. When you draw this velocity time graph, you must understand, if the object is thrown vertical upward, then it turns back to the drawer's hand. Izoba njani velocity time graph? Remember that the speed, for example, was 10 initially, sorry for that, was 10 meters per second upward. Then here the speed is 0, which means this speed as inyuka le object siyathini sona, siya decrease. Then xa isehla speed siya increase. Then nalapha izoba ngu-10 but downwards. Okay, so when you draw the graph of an object that is thrown vertical upwards, bovele uzobe kanje qha. Okay, since izotyu ilento ijulwe vertical upwards, therefore the speed will decrease siyofika ku-0, then sinyuke. Okay, So this is your initial velocity, it was 10. Then the final velocity now is also 10, but in the opposite direction. So it's negative. So we have v in meters per second. Okay. Then we have delta t in what? In seconds. Then you're done with the graph. That is velocity type graph. Once the joule vertical upwards, you must know that the speed decreases up to 0. Okay. Then xa ijulwe ibhola le ijulwe vertically downwards, what will happen? So you must know that xa ijulwe vertically downwards from a certain height, the speed increases. Which means if you 10, for example here, meters per second, so the speed will increase maybe to 19 meters per second. So the speed will increase. When you draw the velocity time graph of the object vertically downwards, the speed increases. Meaning that if you 10 wakho lo, then long 19 wakho, your graph will increase like that. Then you are done. Then it reaches the ground. That is simple like that. Otherwise, there is nothing difficult if you are memorized alone. If you are joule upwards, the speed decreases. So, body labeling yakhona, then ngapha lixesha delta t in what? In seconds. Then you are done. So, which means ayikho into ezokusokolisa, uzokhayela nje the initial velocity and the final velocity, and also the time, obvious. Alright, so when it is drawn vertical upwards, let's look at this one. From a certain building, but it was drawn vertical upwards, then yajika. Ngoku ibisanyuka, the speed decreases to 0. The speed decreases to 0, which means your graph will be like this. The speed decreases to 0, then increase. Then you need to know the initial velocity, okay? The velocity here is equal to 0. That is the easiest way of understanding the velocity time graph, okay? That is the easiest way of drawing the velocity time graph. I will come with a full video of all the graphs, but let's just understand this one. Don't forget to subscribe. Thank you.